Hello, I'm Michael Chen, and in this video I'll be explaining how we performed various calculations in our manuscript evaluating the use of an aerosol box during a simulated intubations. The spreadsheet you see here uses synthetic data as an example to illustrate how we derived values from our motion sensors. Columns B through D represent the raw data values which were collected from the sensors, while column A notes the elapsed time for the given trial that the sensors were recording. Although our protocol had participants keep their hands flat on the table at the start of each recording, the sensors typically did not record perfectly zeroed values for their initial measurements. Therefore, we manually zeroed values by offsetting each axis values by their respective initial measurements. This is depicted in columns E through G. As you can see in the formula panel, the cells take the corresponding raw values for each time point and offset them by the initial corresponding values at time point 0. After obtaining the adjusted accelerometry values, we calculated the triaxial root mean squares for each time point, as seen in column H. The root mean square is derived by completing 3 calculations. First, by squaring all the values of a subset. Second, determining the average of those squared values. And third, taking the square root of that average. The first 2 steps can be done using the sum square function in Excel, SUMSQ, then dividing by the number of values in the subset. Using the square root function, SQRT, then takes the square root of the enclosed value. These triaxial root mean squares were converted to z-scores during interim analysis efforts to graphically compare trials with and without the aerosol box, as depicted in figures 15 and 16. To do this, we used the standardize function in Excel, which prompts users to first input the value for which a z-score is desired, followed by the mean of the subset, and lastly, the standard deviation of the subset. We also used the triaxial root mean squares to compare the time-adjusted values for aggregated triaxial root mean squares over time between trials with and without the aerosol box. We first calculated aggregated values of the triaxial root mean squares in column J by adding prior values over time. Then, we simply divided the aggregated triaxial root mean square values by the time elapsed. The final time points values for each trial with the aerosol box was compared to the final value for the corresponding trials without the aerosol box via Wilcoxon signed rank tests to assess whether intubations involving an aerosol box led to statistically significant differences in hand accelerometry, as depicted in Table 3 of the manuscript. The values from this method were also used to graphically compare how general accelerometry differed between corresponding trials, as depicted in figures 5 through 14 of the manuscript. The final derived values from the sensor's raw accelerometry values were the time-adjusted root mean square values for individual axes. As before, we used the sum square function to get the sum of squared values for a single axis, divided by the number of cells to obtain the average squared value, and then took the square root of the average squared value to get the root mean square. The root mean square was then divided by the duration of the trial to obtain time-adjusted single-axis root mean square values. As before, corresponding time-adjusted single-axis root mean square values for each axis in trials with and without the aerosol box were compared using Wilcoxon signed rank tests to assess whether intubations involving an aerosol box led to statistically significant differences in hand accelerometry in individual axes, as depicted in Table 4 of the manuscript.